Hey AP Calc students, time for more FRQs. This is year 2017 on the AB exam, question number 2. Alright, this type of question is another one of the two rates. We have a rate of increase, a rate of decrease, and we're going to be asked all sorts of questions about amounts and rates of change. So, let's see what they have this time. Question says, when a certain grocery store opens, it has 50 pounds of bananas on a display table. Customers remove bananas from the display table at a rate modeled by f of t is equal to 10 plus 0.8 sine of t cubed over 100 for 0 less than or equal to t less than or equal to 12, where f of t is measured in pounds per hour and t is the number of hours the store opened. After the store has been open for 3 hours, store employees add bananas to the display table at a rate modeled by g of t equals 3 plus 2.4 natural log of t squared plus 2t for 3 less than t less than 12, where g of t is measured in pounds per hour and t is the number of hours after the store opened. All right, so the scenario is it's a grocery store and a table of bananas. There's a rate customers take bananas off the table because they're going to purchase them, and then there's a rate that the employees stock the table with bananas, and it just so happens that there's 50 pounds of bananas on the table when the day starts. And another little curveball to keep in mind is that the employees do not start restocking until after the 3rd hour. So this is only from 3 to 12, but this is 0 to 12. Okay, so there's a scenario, two rates, and let's see what letter A asks. All right, letter A. How many pounds of bananas are removed from the display table during the first 2 hours the store is opened? A very straightforward rate question whenever you want to know, when you integrate a rate, what do you get? You get whatever the rate produces. So I want to know how many pounds of bananas were removed in the first 2 hours. Well, then I just need to integrate the rate the bananas were being removed. So the rate they were being removed is the f of t equation. So if I just integrate from 0 to 2 f of t dt, I should be able to get the amount of bananas that were removed from the table. So that's going to be a calculator question. So if we just bring over our calculator and we say, all right, let's just go to our math menu and let's take number 9 and let's integrate from 0 to 2 for the first 2 hours. And then it's the f of t equation, which is the sinusoidal up there. So that will be 10 plus 0.8 t times the sine of t cubed divided by 100. And the variable of integration is t or x for a calculator. And let's see what we get. It looks like 20.0511, so that'll be 20.051. Whoops. So we get 20.051, and the rate was in pounds per hour, so this will be pounds of bananas, or pounds. That's a pretty simple one. Okay, integrate a rate, something's happening, you'll get what the rate produces. Question B says, find f prime of 7 and then use correct units, explain the meaning of it. Well, if we can take a derivative, we should be able to do this. So the function up above there is 10 plus 0.8 sine of t. Now, because this is a calculator question, we want to take advantage of our calculator. So I'm just going to write f prime of 7, and we're going to put that function into the calculator with the derivative feature, and then we'll put in 7 and see what the number is. So once again, under the math menu here, now I'm going to go down to 8, and I'm going to take d dx, and I'm going to put in the same function again here, which was 10 plus 0.8 x times the sine, times the sine of x cubed divided by 100. And we want to evaluate this at 7. So according to our calculator here, the derivative evaluated at 7 is negative 8.1195, so that'll round up to negative 8.120, and we have to put the correct units on here. Well, as we look at this, we want to see that what we took a derivative of was the derivative of the rate the bananas are being removed from the table. So it looks like the rate the bananas are being removed from the table, the rate that rate is changing is negative. Therefore, the rate is decreasing. And the rate is decreasing at this rate per hour per hour. So this is the rate of a rate, and they love to throw this in there on the AP. They love to see if you will catch that the rate of a rate is always going to be units of time squared. So if you're given a rate, which f of t is a rate, and you're asked to take the derivative of a rate, then your units are going to be squared. So f prime of 7 is negative 8.120 pounds per hour, or per hour squared. So what does this mean? Technically, this says that the rate the bananas are being removed is decreasing at a rate of, now since I said decreasing, since I used the word decreasing, if I say decreasing at a negative rate, the decreasing would cancel out the negative and make it positive. So I'm going to say it's decreasing at a rate of 8.120 pounds per hour squared. Now what you could say is you could say the rate the bananas are being removed is changing at a rate of negative. So I'm actually going to write that because some people prefer that. Or the rate is changing at a rate of negative 8.120 pounds per hour squared. Either one is acceptable. So we found what f prime of 7 was, negative 8.120, and using correct units, we explained what it meant. It meant that the rate was changing, or the rate was decreasing. And that's part B. All right, let's move on to part C. Part C says, is the number of pounds of banana on the display table increasing or decreasing at t equals 5? Give a reason for your answer. Well, there's two approaches to this question, and the first thing we should probably investigate is what's going on at time equals 5. So if we figure out what f of 5 is, we could then compare it to what g of 5 is, and then we could see which one's bigger. So let's go ahead and do that. So let's use our calculator again, and let's see if we can figure out what f of 5 is. And so if we put 5 in here, we're going to say 10 plus 0.8 times, and again we're using t as 5, 0.8 times 5 times the sine of 5 cubed over 100. Well, that would be 125 divided by 100. And that value is 13.795, rounding to 13.796. Now let's figure out what g of 5 is. So g of 5 is 3 plus 2.4 times the natural log of 5 squared, which would be 25, plus 5 times 2, which would be 10. And let's see what that number is. That number is 11.533 rounded. Okay, so now we have the two numbers. Let's look at the question again. It says, is the number of pounds of banana on the display table increasing or decreasing at t equals 5? And give a reason. Well, at f of 5 is 13.796, and this would be pounds per hour. And this is how many are being removed or purchased. So I'm going to say this is being removed. And then this here, pounds per hour, this is being restocked. So I'm just going to put the word stocked, so the table is filled back up. So as you can see, there's more being removed than there are being stocked. So it looks like the number is decreasing. So is the number of pounds of banana in the display table increasing or decreasing? I'm going to say decreasing, because f of 5 is greater than g of 5. The amount being removed is greater than the amount being stocked. Now that's one approach to them. Now another approach that always comes up in these types of questions is when you're asked about increasing or decreasing, your logic would say, if you were just doing a normal function, and maybe you were doing curve sketching, if the question was, is this function increasing or decreasing, you would take a derivative and see if it was positive or negative. So the other approach to this question would be, well, instead of just comparing g of 5 to f of 5, I'm going to build a function for how many bananas are on the table at any given time. So this is a common approach with rate questions, and you just build a function. So you want to say, how many bananas are on the table at any given time? Well, it would be our three components that come up a lot. At any given time, there's three things. How many were there when time began, plus, the second thing is, plus how many increased, and then you subtract the third thing, which is how many decreased. You always remember there's three things involved. So to be more precise, for this question, we say, all right, what is our initial amount? Plus, what is our amount of increase? And then we are going to subtract our amount of decrease. In general, that's kind of the template we use. And now we'll get specific for our question. So A of t is equal to the initial amount. Well, the question says it has 50 pounds of bananas on the table when the day begins. Then we're going to put the amount that's increased. Now you got to be careful. The amount of increase was the information for g of t. So that was the second function. But what's also tricky is it only starts after the third hour the store is open. So from 3 to I don't know when, this would be the g function. And I've gone over this little part before. If I have an unknown in my interval, I need to have a different unknown in my integral. So I'm going to change that to an x. I can't have a t. So 50 plus the integral from 3 to t of gx dx. And then I'm going to subtract the entire time there were customers taking off bananas, so I'm going to integrate from 0 to t, and that would be f of x dx. So this would represent how many bananas are on the table at any one time. 50 plus the amount that was increased minus the amount that was decreasing, and I could put t in and figure it out for any one time. So the question is, what's going on at 5? Well, now I need to take my derivative. So what is a prime of t? Derivative of 50 is 0, plus the derivative of an integral. The derivative of the integral, you think of it as kind of canceling it out, then you do the fundamental theorem with my interval values times their derivative. So there's 4 pieces here, so this becomes g of t times 1 minus g of 3 times 0, that's technically the derivative of that integral, minus f of t times 1, which is the derivative of t, minus f of 0 times 0. All of that needs to be there, technically, but look how clean it is when it simplifies. It all reduces down to 0's gone, this is gone, this is gone, and I just wind up with g of t minus f of t. And they wanted this to be known at 5. So g of 5 was up here at 11.553, or I'll actually go ahead and put in g of 5. G of 5 minus f of 5, and that's equal to 11.533 minus 13.796, which is a negative number. So that negative number is less than 0. I'm just going to say is less than 0. So my derivative at 5 is negative. And if I say a prime of 5 is less than 0, so the amount of bananas is decreasing. Okay. Now it's time for part D. Now, part D says, how many pounds of bananas are on the display table at t equals 8? Well, this winds up being a really easy question because of all the work we already did here creating a function for how many bananas are on the table at any one time. Now, if for part C you did it the short way, you would then have to build the function right here in order to do part D. So this part here where we came up with the function for how many bananas are on the table at any one time, I'm going to take that part because that's what we need here to do part D. So I'm just going to recopy that equation. So the equation we built was the amount of bananas on a table at any given time is 50 plus the integral from 3 to t, because this is when the workers restock the table, of g of x dx. Then we would subtract the amount being purchased all day by customers from 0 to t at f of x dx. So we're just borrowing that, and the question says how many are on there at 8, at time equals 8. So all we need to do is put an 8 in here. So that is equal to 50 plus the integral from 3 to 8 of the g of x function minus the integral from 0 to 8 of the f of x function. And then we just go to our calculator and put that in. So our final part here, we could put this in as one big problem here. So this is what we're going to do. So I'm actually going to just say it's going to be 50 plus, and under the math menu, I'm going to hit number 9, and I'm going to integrate from 3 rather to 8, and that is the g function. Now the g function was the natural logarithm, so that was 3 plus 2.4 times the natural log of t squared plus 2t, and my variable of integration there would be x. I sometimes interchange saying x and t because the calculator is going to default to t here. And then I'm going to subtract the integral, so back to my math menu here, subtracting the integral. This one does get to go all the way from 0 to 8 because this is the customer's purchasing, and this is once again this 10 plus 0.8 t or x times the sine of x cubed divided by 100, and that variable of integration is also x or t in this case. So that's what it should be. We have 8 in there, and letting the calculator do the work for us, we wind up with a of 8 is equal to 23.34, it's a decimal there, 0.347, and that would be pounds. And that is the final part of part D. So, once again, AB exam, year 2017, question number 2, a 2 rates question, 2 rate style, and this one was the rate bananas are placed on a table, the rate bananas are taken off of a table. The day begins with 50 pounds, and just manipulating your knowledge as the problem goes. All right? Thanks for watching. We'll see you next time.